This video is on comparing functions represented differently. Just for foundation, we're going to recall that a function is a relation where each x value of the domain is mapped with exactly one y value of the range. On the left-hand side, we see what is a function, and on the right-hand side, we see what is not a function. And this is not a function because you notice that 93, which is in the domain, is actually being mapped to two completely different values, and that's what you can't do. It is a relation, but it's not a function. Linear functions can be represented in various ways. You might see it in a table format with xy values. You might see it as a graphed line. Or you might see it in equation form, where a function of x equals 4x plus 6, and you would see this in terms of y. Given linear function 1 and 2, which function has the greater rate of change? What does greater rate of change mean in terms of a graphed line? Well, it's the slope of the line. So there's a couple different ways you could solve this problem. One way to figure this out is to graph the xy coordinates from the table on the graph of function 1. So we know that we already had the first line, and that's the red line, and we can figure out the slope of that over 1 and up 4, and we come up with the equation for that line, y equals 4x plus 6. And then we would take the points from the table and we would graph them. And when we graph the points, then we draw a straight line through it. And we find that the slope of this line is 1. The equation being y equals x plus 4. So then all we have to do is compare the slopes of the two lines. We see that function 1 has the larger slope, which means the rate of change is greater. Well, here's another way we could look at the same problem. We could find the slope of the line that we already had on the graph. We find that it is 4. And then we could look at the table and we could use the slope formula, change of y over change of x. We could calculate the slope that way, and we would come up with y equals x plus 4. Remember that 4 is the y-intercept, and where the y-intercept is where x is 0. So that's how we came up with that. So once again, we find out that the slope is 1, and we would compare the slopes. Which of these linear functions has a smaller rate of change? So we have function 1, which is given to us in equation format, and then we have function 2, which is given to us in a line format. Can you think of two different ways that we could figure this out? Well, here's one method. You find the slope of the line, the one that's graphed, and we find that the slope is minus 2. And then we put function 1 in the slope-intercept format, and then we compare the slopes. So negative 1/2 y equals x minus 6. We multiply both sides by negative 2, and we end up with y equals minus 2x plus 12. You'll notice that the slopes are the same. So which one has the smaller rate of change? The other method is to graph the first function with the second. So we have function 1 already on the graph, y equals minus 2x plus 12. I'm sorry, y equals minus 2x. This is the one that we had on the graph. Minus 2x plus 3. And then we would graph the first function on the same graph and we find y equals minus 2x plus 12. That's after we put it in slope-intercept format. And we recognize that parallel lines have the same rate of change because their slopes are equal. So once we graph both lines and we see that they're clearly parallel, then we would already be able to say, hey, the rate of change for these is the same. Alright, that ends this very brief introductory video of how to compare linear functions that are represented in different ways. Remember, they can be represented as values in a table. You might see it in an equation, or you might see a graphed line. Enjoy the activity.